Glass is so familiar in our daily lives that we rarely stop to notice it. It's in the jars that hold our food, the windows that frame our homes, and the screens we tap on every day. Yet all of it begins with something unbelievably ordinary: tiny grains of sand. Every year, more than 60 million tons of high-purity silica sand are extracted and sent into factories where remarkable transformations unfold. Inside the largest glass plant in the United States, this sand takes on an entirely new identity. Here, massive machines, roaring furnaces, and precisely timed systems work together in perfect synchronization. What enters the facility as raw, unremarkable grains soon becomes the clear, solid material that shapes so much of modern life. As we step inside this mega factory, we'll uncover how something nearly invisible beneath our feet turns into the bottles, panels, and glass products we depend on every single day. Glass may feel like a modern invention, but its story reaches back more than 2,000 years. According to historical records, ancient Egyptian craftsmen around 300 BC accidentally discovered glass while heating silica sand mixed with natural minerals near an open fire. What they created, clear, solid, and unlike anything seen before, became one of humanity's most enduring materials. What makes glass so remarkable is its internal structure. It's transparent like crystal, resistant to heat, corrosion, and even electricity. It doesn't rust, it doesn't dissolve, and when made correctly, it can last for centuries without losing clarity. And perhaps its most impressive trait is that it can be recycled endlessly without degrading in quality. Yet glass carries a contradiction. It's strong but fragile, rigid but delicate. Push it beyond its limit, and it doesn't bend, it shatters. This paradox sets the stage for the extraordinary engineering required to craft it on an industrial scale. To create high-quality glass, not just any sand will do. Manufacturers need an extremely pure form of silica, with a concentration reaching up to 99%, far beyond what you'd find on typical beaches or desert dunes. This special sand is buried deep within large open-pit mines, locked inside dense layers of rock. The extraction process begins with controlled industrial explosions that fracture the rock into manageable pieces. Within seconds, massive excavators roll into position, scooping up the shattered debris and loading it into heavy-duty haul trucks. Each truck carries several tons of raw material, rumbling across rough terrain toward the next stage of processing. From above, the mine looks like a vast, stepped canyon carved by machines rather than nature. Dust clouds rise, engines roar, and the operation runs with military-like precision. Every movement is calculated to keep the flow of silica constant. By the time the trucks reach the crushing facility, the raw rock still looks nothing like the fine, pristine sand needed for glassmaking. But this is only the beginning. The grains hidden within these chunks will soon undergo an intense transformation long before they ever see the inside of a furnace. Even after the rock has been blasted apart and crushed, the material is still far from ready for glassmaking. To reach the level of purity required, the silica must go through an intensive, multi-stage purification process. It begins as the crushed material is dumped into a large hopper that feeds it into a controlled flow system. The first stop is a precision screen, often a 30-mesh sieve, that filters out oversized particles and ensures only uniform grains move forward. From there, the sand enters powerful agitation tanks, where high-pressure water jets strike with needle-like force, stripping away clay, dust, and any contaminants still clinging to the grains. After nearly 15 minutes of continuous washing, the mixture flows into a spiral separator. Here, centrifugal force takes over. Heavier metallic fragments are pushed outward and removed, while the lighter, cleaner sand travels to the next stage. A magnetic separator then captures any remaining traces of iron, ensuring the silica meets strict industrial standards. Once fully purified, the sand is dried, packed into 1-ton industrial bags, and shipped to the glass factory, finally ready to begin its transformation from raw mineral to molten clarity. When the purified silica finally arrives at the glass plant, it enters a carefully controlled preparation stage. Although silica is the main ingredient, it can't become glass on its own. Technicians blend it with sodium carbonate and calcium carbonate, two critical additives that change the structure of the silica, lower the melting point, and improve the durability of the final product. If a specific color is required, pigments like cobalt oxide are introduced in precise, measured amounts. Even the smallest variation can impact transparency, strength, or hue, so every component is handled with laboratory-level accuracy. Once the ingredients are weighed and verified, they're released into a filtration system that removes any final impurities. From there, massive conveyor belts take over. These belts move hundreds of tons of material each hour, delivering the raw batch to a mixing zone where high-speed industrial stirrers spin relentlessly. Inside these mixers, each grain of sand is blended evenly and subjected to a final deep cleaning. The mixture begins to take on a uniform consistency, the last step before facing the extreme heat of the furnace. What was once simple sand is now a meticulously engineered recipe, ready to melt into liquid glass. With the ingredients perfectly blended, the mixture moves toward the heart of the entire operation, the melting furnace. This massive gas-fired chamber operates at an astonishing 1650 degrees, hotter than molten lava, and runs non-stop, day and night. As the raw batch enters the furnace, the intense heat begins breaking down the structure of the sand, causing it to soften, fuse, and eventually transform into a glowing, liquid aaye mass. Technicians monitor the entire process from a control room, adjusting temperature, airflow, and timing with extreme precision. Inside the furnace, the material slowly transitions from a grainy mixture to a smooth, honey-like flow. Workers nearby must wear fire-resistant suits, heavy visors, and Kevlar gloves to withstand the radiant heat that pours from every opening. For nearly 24 hours, the molten material is held at high temperature, allowing trapped gases to escape. This stage is crucial. A single bubble or impurity can weaken the final glass. As the mixture settles, the surface glows a brilliant orange, moving like thick lava. What emerges at the bottom of the furnace is no longer sand at all. It is fully molten glass, perfectly purified, and at the ideal viscosity, ready to be shaped into the countless glass products we rely on every day. Once the molten glass reaches the perfect viscosity, it begins its journey into the forming line. The glowing liquid flows through special channels before being cut into measured drops called gobs. Each gob falls with a heavy, glowing thud, still more than once at 100 degrees, and contains just the right amount of material to make a single bottle. These gobs drop into the first stage of shaping, the preliminary mold. Here, a burst of compressed air forces the hot glass outward, creating a hollow preform known as a parasone. This early shape resembles an upside-down bubble with a narrow neck, still glowing bright orange as it rotates gently within the mold. Just inches away sits the final mold. The parison is transferred with remarkable speed and precision, then hit with a second blast of air. The soft glass stretches outward, hugging every contour of the mold cavity. Within seconds, a fully formed bottle appears, perfectly smooth, perfectly uniform. Behind the scenes, an intricate network of valves, sensors, and timing systems works in flawless synchronization. Each movement is timed down to the millisecond. This level of control allows the factory to produce hundreds of thousands of identical bottles every day, each one emerging from the line almost perfectly formed. Fresh from the molds, the newly formed bottles are still glowing red at the base and far too fragile to touch. At this stage, any sudden change in temperature could cause them to crack or shatter instantly. To prevent this, the bottles are gently placed onto a conveyor that guides them into a long, tunnel-like chamber known as the annealing layer. Inside this chamber, the temperature is carefully controlled and gradually reduced in multiple stages. The bottles first pass through zones that remain extremely hot, allowing the internal stresses within the glass to settle. As they move forward, the heat slowly decreases, giving the bottles enough time to stabilize without developing microscopic fractures. This slow, deliberate cooling process is essential to the strength of the final product. Rush it, even by a few seconds, and the glass could weaken or distort. Depending on the bottle size and thickness, the annealing process can take several minutes, sometimes even longer. By the time the bottles exit the other end of the leer, they have completed their transition from delicate, molten forms into solid, durable containers ready for the next stage of inspection. Once the bottles have fully cooled, they enter one of the most critical stages of production: quality inspection. Here, an entire network of high-speed cameras, optical sensors, and precision scanners analyzes each bottle in real time as it moves along the conveyor. Every detail is examined, far beyond what the human eye could detect. The system checks for cracks, bubbles, scratches, uneven walls, and even tiny distortions invisible to most people. If a flaw is detected, the bottle is instantly removed from the line with a quick mechanical push, ensuring only perfect products move forward. Next, the bottle's mouth undergoes a specialized inspection. Mechanical probes and rotating sensors measure the rim with micrometer-level accuracy. A chipped edge or a slightly irregular opening can compromise sealing, so this step is non-negotiable. This automated process ensures consistency across hundreds of thousands of units. By the end of the inspection zone, only bottles that meet the highest safety and quality standards are allowed to continue to the final stage of production. After passing every inspection, the finished bottles enter the palletizing area, an orchestrated dance of robotic arms and conveyor systems. With precise, fluid motion, the robots lower their clamp-equipped frames, lift entire rows of bottles at once, and place them neatly onto pallet layers. A protective sheet is added between each layer to prevent scratches or impact during transport. Once a pallet is fully stacked, an automatic wrapping machine seals it tightly in industrial film, securing every bottle in place. A printed label is then applied, marking the batch number, production line, and date. Information that ensures full traceability from the factory to the final destination. From here, forklifts move the wrapped pallets to the loading zone, where they wait to be shipped to beverage companies, food manufacturers, or distributors around the world. It's a fitting end to an incredible transformation. What began as invisible grains of sand now stands as thousands of perfectly formed glass bottles, ready to be filled, sealed, shipped, and used in everyday life.